All right, folks, in the last video, we didn't really have enough time to go over more than one or two examples. So what I want to do is, I just want to do examples in this video, and hopefully that this can help you understand how to identify the equation of a function. You're given a graph, you got to find out the function. So I'm looking at this. When I first approach one, here's my first thought is, does it have a horizontal asymptote or does it have a vertical asymptote? The way I'm going to tell the difference is this, is if horizontally, if the graph basically comes in line with one of the grid lines, if it basically goes horizontally flat, then it's a horizontal asymptote. If it goes vertically flat, meaning vertically steep, like it's drawing a straight line up, then it's a vertical asymptote. Now you'll notice this one is not going too terribly vertical, but it is going very horizontal. It's practically a straight line in the horizontal direction. That means that this graph has a horizontal asymptote. And the first thing that I'm going to do is I'm going to draw in the horizontal asymptote, which is right here. And that's what you should do if you're doing a problem like this on your paper, is to draw in the horizontal asymptote. That horizontal asymptote is very important. It's going to help you answer a part of your, it's going to actually help you in a few different places in this problem. So that's the first thing you're going to do, is draw in the horizontal asymptote. Since it's a horizontal asymptote, it must be an exponential function, because only exponential functions have horizontal asymptotes. If it had a vertical asymptote, then it would be a logarithmic function. But this is a horizontal asymptote, so it's an exponential function. So we know that it's going to be y equals base to the x plus or minus something power plus k. All right? So it's going to be like, but we don't know what the base is. We don't know what the horizontal shift is, and we don't know what the vertical shift is. We have to find those things out. So, the first thing we want to find is the base. The way you find the base goes like this. There's 2 points that are important. Only 2 points really that are important on an exponential or logarithmic function. One of them is where the graph intersects the line that is 1 unit away from the asymptote, but parallel to the asymptote. So, here's the asymptote. If I go 1 unit up, this line is 1 unit away, but parallel to the asymptote. And where does that line cross over the graph? Well, it crosses right here. And so that is the point that is important to me. And now I don't need this line anymore. And eventually what happens is, after a while, you do this in your brain. You don't even have to draw the line. I'm just like, oh, there's my asymptote. I'm going to go 1 away. I'm going to go over to the curve. Boop, there's my point. Ta-da, I got it. That point is the same, basically the same thing as the point 0, 1, the one that would be way over here. And whatever shift this point is from here, that's your horizontal and vertical shift. But we'll get to that later. Okay? All right, so now, the second point, you have to go 1 unit over from that point. Now, whether you go to the right or to the left, or up or down, depends on where the asymptote is and what direction the graph is opening. When I say opening, look, it's opening to the left. We want to be under the curve. If I go to the right, I'll be above the curve. I don't want to be above the curve. I want to be under the curve. So I want to go over here. So I'm going to go over here where I'm under the curve, and then I'm going to go up to the curve and put a point. Now, if this graph was upside down, if it was down on the bottom of the asymptote, then I wouldn't want to be under the curve. I'd want to be above the curve. And I know that sounds crazy, but you have to understand that every single time you reflect this thing, you change where you want to be. And that's one of the reasons why you have to spend a lot of time you know, basically what you want to do is you want to be between the asymptote and the curve, because this distance is what matters. So once I plot the first point, and typically what I tell students to do is go over 1 unit from that point, then go up or down to the asymptote, then go up to the curve. So we're going to count from the asymptote. 1, 2, 3. So this point is 3 units from the asymptote. That means that the base of this exponential function is 3. This distance tells you what the base of the function is. And we'll do a few more examples so you'll see what I'm talking about. All right, so we got that. Now, we want to know what the vertical shift is, right? What we're going to put in here for the k. Well, on an exponential function, all you have to do is look at where the asymptote is. Well, where is the horizontal asymptote? It's at, if this is the origin, the horizontal asymptote is 1, 2 down. That's -2, right? That number is what you're going to put on the end, -2. There we go. It's a downward 2 shift. Lastly, we want to know what to put inside with the x, right? Well, you want to look at this dot right here, the very first one you drew, the one that's 1 unit away from the asymptote. How far is this dot from the y-axis? How far over is it? It's 1, 2, 3, 4, 5, 6 units over to the left. So it is a left 6, which in a way we can say is a -6 shift. But when we put it with the x, we have to put the opposite sign. So instead of -6, we're going to put +6. So +6. The last thing we want to know is, or the last two things is the graph upside down and is it backwards? Well, the normal exponential graph, and this is one of the reasons why I wanted you to memorize what the normal one looks like. The regular graph looks like this. Is this backwards from this? Is it flipped backwards? Normally, the asymptote goes off to the left, but in this one, the asymptote goes off to the right. Therefore, this graph is backwards. When it's backwards, we put a negative in front of the exponent, in front of the parentheses of the exponent. Lastly, if it's upside down means it's flipped vertically, okay? And in the case of an exponential function, it would be under the asymptote. Well, it's not under the asymptote. It's above the asymptote, so it's not upside down. So we're not going to put a negative. And therefore, the graph of this function is y equals 3 to the power of negative x plus 6 minus 2. All right? Let's try another one. So now, the very first thing we want to do is we want to try and identify the asymptote. Well, it's flat here, and up here it starts to go vertical, but it's not straight line vertical. Down here it is straight line flat, so this one has a horizontal asymptote, meaning that this one is also an exponential function. So first thing I'm going to do is draw in the asymptote. Second step, go 1 unit up from the asymptote and go over to the curve, which is right here, and put a dot. From there, go 1 unit over and then go up to the curve and put a dot there. Now, measure the distance between that dot and the asymptote. This distance is 2. 1, 2. That means the base is 2. This is y equals base 2. Now, is there a vertical shift? Yep. It goes, the asymptote is going through y equals -3, right? -3. Down 1, down 2, down 3. So we're going to put a -3 on the end. And then this dot right here, how far is that dot from the y-axis? 1, 2, 3, 4 to the right. So right 4. That means a +4 shift. But we have to reverse the sign, and it becomes x minus 4. So we're going to put to the power of x minus 4. So we shifted to the right 4 and down 3. Right 4 and down 3. Now we got to ask, is this upside down or backwards? Well, this exponential function is above the asymptote, so it's not upside down, so we're not going to put a negative in front of it. It's also not backwards because it looks like the normal shape of an exponential function. The asymptote is going to the left, so it's not backwards. So we're not going to put a negative here, and that is the equation of this exponential function. Okay? Let's try another one. So now the first thing we want to do is see if there's or see where the asymptote is. Well, horizontally, it doesn't look like it's flattening out all the way. It's getting flatter, but it's not going straight sideways. But look at this. Right here, it is going straight vertically, which means that this has a vertical asymptote, not a horizontal asymptote. If it has a vertical asymptote instead of a horizontal asymptote, it must be a log function. I got to use a different color. It must be a log function instead of an exponential function. So here we go. There's our vertical asymptote. And now what we're going to do is, for a logarithm, instead of going one unit up, we can't go up or down from the asymptote. It's a vertical asymptote, so we're going to go sideways, either one this way or one this way. Well, the graph is over on the right side, so we're going to go one unit over and then find the point, or find the curve. There we go. That's the only point that is one unit to the right of this asymptote. And now, instead of going left or right into the curve, we're going to go up or down into the curve. So we're going to travel along the asymptote, or parallel to the asymptote. We're going to go this direction because that's where it's opening, right? And then we're going to go over to the curve, which is right here. And then we're going to measure our distance from here, from the asymptote, over to that point, which is 1, 2. So the distance of 2, that means the base is 2. So this is going to be y equals log base 2. Okay? Now we want to know what the horizontal shift and the vertical shift is. So now the asymptote will tell us what the left and right shift is. Normally this asymptote is at the y-axis, and it's moved 1, 2, 3, 4 units to the left. It's 4 units to the left. Okay? That means it's a -4 shift, but remember, and horizontal shifts go with the x. But we don't put -4, we put the opposite. It would be x plus 4. So we know that we're going to have an x plus 4 inside the parentheses. Okay? What about a vertical shift? Well, this dot, the very first dot, just like on the exponential, the first dot is going to tell us what the vertical shift is. This dot is supposed to be on the x-axis. So the distance, how far this is from the x-axis, that's going to tell us the shift. How far is this dot from here? Well, it's 2 units up, right? So that is a +2 shift, so I'll put a +2 on the end. Lastly, is this graph backwards or is it upside down? Backwards would mean that it is on the left side of the asymptote, because logarithmic functions are normally on the right side of the asymptote. This graph is on the right side of the asymptote, so it is not backwards. Therefore, we will not put a negative in with the x. It is also not upside down. Normal logarithmic functions have the vertical asymptote points down, right? Well, this one is pointing down. Look, the curve on the left-hand side is pointing down. It's not pointing up, so it is not flipped upside down. Therefore, we're not going to put a negative, and this is the equation of this logarithmic function. Let's try another one. All right, here's another one. Why don't you pause it and try this one? All right, here's what I'm thinking. I'm looking for an asymptote, and I'm either looking for a horizontal asymptote or a vertical asymptote. Does the sideways look like it's flattened out entirely, or does the vertical look like it's flattened out entirely? Looks to me like this is a vertical asymptote, right? So we're going to draw a vertical asymptote here. So that must mean that this is a logarithmic function. So this one's going to be y equals log. We got to find out what the base is. So we're going to go 1 unit over from the asymptote and then go to where the curve is, 1 unit away from the asymptote, and put a dot. Then we're going to go one more unit away from that dot, but we're going to go down. Why are we going down? Because that's where it opens up. So we're going to go down here, and from the asymptote, we're going to go over and put a dot, which is right about here. Now, how far is that dot from the asymptote? It's 1, 2, 3, 4, 5. And because it's 5 units away from the asymptote, that must mean that it has a base of 5. So this is log base 5. Okay? Now, I need to know whether there's an up or down shift or a left or right shift. The left and right shift goes with the x, correct? So I'm going to have x with something in here. Well, this asymptote is, normally this asymptote is at the y-axis, but it's moved over 1, 2, 3 to the left. 3 left. That's a -3 shift, but because it's an x shift, we reverse the sign. Instead of -3, we put x plus 3. So we're going to have x plus 3. How about the vertical shift? Well, this dot, the very first dot that we always plot when we're doing this, is normally on the x-axis. Well, how far down is this? 1, 2, 3, 4 units down from the x-axis. That's -4. Lastly, we got to know, is it flipped backwards or is it flipped upside down or both? Normally, the logarithm function is on the right side of the graph, or the asymptote, not the left side of the asymptote. And this graph is on the right side of the asymptote, so it is not backwards. So we are not going to put a negative inside with the x. However, normally, this vertical part points down, not up. So you'll notice, normally the logarithm graph looks like this, but this is flipped upside down. And therefore, we're going to put a negative in front of the entire thing, and our final function is y equals negative log base 5 of x plus 3 minus 4. Okay? And that is our function. All right, let's try another one. Okay? All right, got to decide. Let's see here. All right, why don't you pause it for a second, see if you can find the asymptote. All right, so I'm looking at this, and it's either a vertical asymptote or it's a horizontal asymptote. And it looks like this is where it's becoming a straight line flat. So that is where I'm going to put the asymptote. It looks like it's a horizontal asymptote, and it looks like, so that means it's an exponential function. And so now I want to go 1 unit away from the asymptote toward the curve. So this time I'm going to go down. And I want to go over to the curve 1 unit away from the asymptote, and I'm going to put a dot. So there's my first dot. Then I want to go 1 unit over from that, and then go to the curve and put a dot again. This is going to tell me what my base is. How far is this dot from this asymptote? It's 1, 2, 3 units. So this exponential function has a base of 3. Now I got to find out what my horizontal shift is and what is my vertical shift. Well, this asymptote is moved up from the y-axis, or excuse me, from the x-axis, sorry. And so it's up 1, 2, 3, 4, positive 4. So it's up 4, so I know that I'm going to have a plus 4 on the end of the function. This dot, the original dot, is moved 1 unit to the right. That's a plus 1 shift, plus 1 x shift, but you know we do the reverse, so it's x minus 1. And so, in the parentheses up here, I'm going to put x minus 1 for the exponent. So this is a rightward shift, an up shift. Lastly, I just need to know if this graph is upside down or backwards. Okay, well, normally the asymptote trails off to the left, and it does here. It's trailing off to the left, like the normal exponential curve. But instead of being above the asymptote, this graph is below the asymptote. So it is not backwards, but it is upside down. So upside down means I put a negative in front of the base, and our final function is y equals negative 3 to the power of x minus 1 plus 4. Okay? Let's try another one. Let's identify the asymptote first. Why don't you pause it? Why don't you try and figure out the whole thing if you can. All right, so I'm looking for, is this a vertical asymptote, making it a logarithm, or is it a horizontal asymptote, making it an exponential function? Well, it looks to me like it doesn't really go perfectly vertical. It does, however, go perfectly horizontal, meaning it looks like there's an asymptote at a horizontal asymptote, which means that this is an exponential function. We got to find the base, and the way we find the base is we go 1 unit away from the asymptote. We're going down because the graph is below, meaning it's upside down. So we're going below, then over to the curve and putting a dot. From that point, we're going to go 1 unit over and then go to the curve, which is way down here, and put a dot. 1 unit over and at the curve. Okay? So basically, we're following along the curve until it hits hits the next line here. And we're putting a dot there. How far is it from the asymptote to this dot? It's 1, 2, 3, 4. That means the base is 4. So this is going to be y equals base of 4. Now, we need to know the vertical shift and the horizontal shift. Well, this asymptote is 1, 2, 3 units up from the x-axis. Therefore, that's a plus 3. So we're going to put a plus 3 on the end. And this dot, that very first dot that we plot, how far is that from the y-axis? It's 1, 2, 3 units over. Okay? So that is a minus 3 shift. But remember, we flipped the sign, so it's x plus 3. So in the exponent, we're going to put x plus 3. Okay? Now we just need to find out whether it's upside down and backwards and put our negatives on. Okay? This graph is below the asymptote, meaning it's upside down. So we're going to put a negative on the front. Also, it's backwards, because normally the asymptote, or the graph, follows the asymptote to the left. But this one is following the asymptote to the right, and therefore it's flipped backwards. Therefore, we would put a negative in the exponent outside of the parentheses. And that is the function. That's the equation of this graph. Y equals negative 4 to the power of negative x plus 3 plus 3. Okay? Should we try another one? Absolutely. All right. This one, we're looking for the asymptote first. Do you want to pause it and try it? All right. So does it look like it's going perfectly flat sideways or perfectly flat vertically? It looks like it's going perfectly flat vertically here. So this must have a vertical asymptote. So we'll draw a vertical asymptote right here, which must mean that this is a logarithmic function. If it is a logarithmic function, it looks to me like it's flipped upside down, because normally logarithmic functions do this, right? They come from the bottom and go towards the top. This one's coming from the top and going towards the bottom, so it must be upside down. Also, logarithmic functions are normally on the right side of the asymptote, and this one is on the right side of the asymptote, therefore it is not backwards, but it is upside down. Let's find the base of this logarithmic function. Well, to find the base, we got to plot our first point, then our second point, and it's the second point that tells us the base. The first point is going to be 1 unit away from the asymptote. So go 1 unit away from the asymptote and then go to the curve. Follow along to the curve. That's right there. We're going to put that dot right there. Then we're going to go 1 unit away from that dot, which is down here. We got to go, remember, we got to go the direction that it opens. So down here, then we're going to go over to the curve and put a dot. Okay? How far is that dot from the asymptote? Well, it's from here, 1, 2, 3, 4. Now, be careful. Do not say 1 when you put your pencil on the asymptote. Because when you're on the asymptote, how far are you from the asymptote? You are 0 units away from the asymptote. So it's 0, 1, 2, 3, 4 units away. Okay? So that's a base of 4. So this is going to be y equals log base 4. Little 4 down here, right? Okay, good. Now, we're going to put, we now have to find our vertical shift and our horizontal shift. Okay, well, the horizontal shift is told by the asymptote. Normally, the asymptote, this vertical asymptote, is at the y-axis. Well, how far over is it? It's 1, 2 units to the right. 2 units to the right is a positive shift, so that's plus 2 to the right, except that we change the sign because it's with the x. So it's x minus 2. So this is going to be x minus 2. How about the vertical shift? Well, the vertical shift is told by the very first point that we plotted. That point is normally supposed to be on the x-axis. It is 1 unit down from the x-axis. That's a -1. So we're going to put a -1 on the end of the function. Lastly, upside down or backwards. Well, we talked about that a minute ago. It's not backwards. It's not on the left side. It's on the right side of the asymptote, so it's not backwards. So we're not going to put a negative in here. However, it is upside down. Therefore, we're going to put a negative in front of the logarithm, and our function is y equals negative log base 4 of x minus 2 minus 1. Okay? Let's do another one. This one is kind of over there in the corner, so it's kind of hard to tell where the asymptote is. But I can see this. On this one, on the vertical, it's kind of at an angle, and on the horizontal, it does look like it's just going flat. So it looks to me like there's a horizontal asymptote. So we're going to draw in a horizontal asymptote here, -1. It's a terrible horizontal asymptote, but there it is nonetheless. It's at -1. All right, now, to find the base of this exponential function, and it is exponential because it has a horizontal asymptote, we have to go 1 unit away from the asymptote and then over to the curve and plot a point. Then we're going to go 1 unit over from that and go to the curve and plot another point. How far is that point from the asymptote? It's 1, 2 units away. This is a distance of 2. Therefore, this is an exponential function with a base of 2. So this is y equals base of 2. Now we need the horizontal shift and the vertical shift. Okay, vertically, the asymptote is normally on the x-axis, but it's down 1 unit, so that's a -1 shift. So we're going to put a -1 over here. Then we're going to do, we need to know the horizontal shift. Well, that first point that we plot always tells us our horizontal shift. How far is that from the other axis? It's normally on the y-axis for an exponential function, and so it's 2 units to the right. That's a +2 shift, but we reverse the sign, so it's x minus 2. So we're going to put x minus 2 up there in the exponent. Lastly, is this graph upside down, or is it backwards, or both? Well, exponential functions are normally above the asymptote, but this graph is below the asymptote, so it's upside down. So we're going to put a negative in front of the 2. Also, the asymptote, the graph normally follows the asymptote to the left. Okay, the normal curve, the normal exponential function looks like that. And not only is the graph below the asymptote, but it's also been flipped so that the graph follows the asymptote off to the right instead of the left. So it's also backwards. And so because it's backwards, we're going to put a negative in front of the exponent. Okay? Let's do another one. All right, let's try this one. This one's actually hard to tell where the asymptote is because, look, this doesn't really go flat and this doesn't really go flat. So you kind of have to make a judgment call here. Okay? Here's the interesting thing. It looks to me like it's flatter here, and I know that makes you think that it should then be a horizontal asymptote, but it looks like it's never actually going to become flat, okay? That indicates to me that this is probably a logarithm, because look what happens here. See this steepness here? It looks like it's about to go vertical. See, I wouldn't know where to put the horizontal asymptote. If I put it here, I don't know for sure. But look at this. Right at the end here, it's so steep that it seems pretty apparent to me that this one has a vertical asymptote here. And I know it's a judgment call, but you have to do the best that you can when you have these graphs. Okay? So I'm going to put the vertical asymptote there. Now, I need to identify the base. And so first, I need to plot my first point. I'm going to go 1 unit away from the asymptote and plot a point. Then I'm going to go 1 unit away from that and go over to the curve and plot another point. Okay? How far is this point from the asymptote? It's 1, 2 units away. So this is a base of 2. And because it has a vertical asymptote, it's a logarithm. So this is going to be y equals log base 2. Okay? Now, we got to find out the left or right shift, and then the vertical shift. It looks, since the asymptote is normally supposed to be at the y-axis, it looks like it's 1, 2, 3, 4, 5 units to the right. That's a plus 5 shift, x shift, but we reverse the sign, so it's x minus 5. So we're going to put x minus 5, okay? And then the vertical shift. This first dot that we plotted there, that's normally on the or on the x-axis. And so, but it looks like it's above the x-axis. How far above? It's 1, 2, 3 units above. That's a plus 3 vertical shift. So I'm going to put a plus 3 up here. Now we got to identify whether it's backwards or upside down or both or neither, okay? Well, normally a logarithmic function is on the right side, and it normally points down instead of up. That's a normal logarithmic function. It follows the asymptote down. This one follows the asymptote up. Therefore, it's upside down. Also, this logarithmic function is on the left side, not on the right side of the curve, and therefore it is also backwards. So we're going to put a negative in front of the logarithm, and we're going to put a negative inside with the x. But watch this. When I put it inside with the x, I need to put parentheses around the x minus 5. So it's negative the quantity of x minus 5. And this is the function for this graph. Okay? Let's try another one. All right, let's see if you can figure this one out. All right, let's see. We need the asymptote. Well, it looks to me like it gets flat with a straight line horizontally right here. So there must be a horizontal asymptote right here. Okay? Now, we need to identify the base of this exponential function. And so what I'm going to do is I'm going to go 1 unit away from the asymptote and then go over to the curve and put a dot. That's the first dot. The second dot is going to go 1 unit over from that and then at the curve, which is actually way down here, right here. Now notice that the curve is underneath the asymptote. That means that it is upside down. Okay, so it's going to have a negative on the front of the base, on the front of the function. Okay, so now how far is this dot from the asymptote? It's 1, 2, 3, 4, 5. So this function has a base of 5. And so we're going to say y is equal to 5 and then to the power of something. Well, let's find out what it should be the power of 2. We're going to do what's the vertical shift and what's the horizontal shift. Well, normally this asymptote is on the x-axis, but it's up 2 units. Therefore, it's going to have a plus 2 at the end of it. And this dot is normally supposed to be on the y-axis. So how far over is it? 1, 2, 3. So that's a negative 3 shift. So we're going to say x plus 3. So this is to the power of x plus 3. Lastly, is this graph backwards? Well, it is not backwards because normally the asymptote, or the graph of an exponential function, follows the asymptote to the left. And it is following the asymptote to the left. So it's not backwards. But is it upside down? Yes, because normally an exponential function is above the asymptote, and this one is below the asymptote. Therefore, it's upside down, and we're going to put a negative in front of the 5. So our function is negative 5 to the power of x plus 3 plus 2. Let's try one more. All right, this one's kind of hard to see for the asymptote, but you can see that here it's not zeroing in on a line, but if you notice right there, it's just barely starting to become vertical. So this one's got a vertical asymptote here at positive 1, at x equals 1. So we're going to put the asymptote right in here. So it must be a logarithmic function. Now to find out what the base is, we're going to go 1 unit over from the asymptote and go to the curve and put a dot. From that dot, we're going to go 1 unit away and then over to the curve, and we're going to put in a dot. How far is that dot from the asymptote? It's 1, 2, 3 units. So this logarithm is log base 3. Okay, so y equals log base 3. Now we got to do the vertical and the horizontal shift. Well, this asymptote is 1 unit to the right. So that's an x shift of positive 1. But we got to reverse the sign. So instead of x plus 1, it's x minus 1. So we're going to put x minus 1. Then the vertical shift. This dot, the first dot that we plotted, is normally on the x-axis, right? And so it's shifted down. How far? 1, 2, 3. So that's down 3, that's minus 3. So we're going to put a minus 3 on the end here. And now we got to, is this upside down or backwards? It's not backwards because the graph is normally on the right side of the asymptote. But it is, and it's not upside down because the asymptote is going in its, or the graph is following the asymptote down, which is normal. So this is neither upside down nor is it backwards. And so this is the equation of that. This is the function that goes with that graph. Okay. All right, I'm going to try maybe do another video with a few more examples, maybe some of the ones from your worksheet. I'll see if I can. But hopefully, if you go back through this video a couple times, you can see that I keep doing the same thing over and over again. It's always asymptote, first dot, second dot, identify the base, identify the vertical and horizontal shift, then identify whether it's upside down or backwards. Okay, and that's the same for all of them. Okay. All right, well, good luck, and I'll see you in class.